Hello, everyone. Welcome to this special webinar about Oklahoma climate and drought impacts. My name is Joel Lisenby. I am a climatologist and a drought information coordinator at the National Integrated Drought Information System, or NIDIS. If you are not familiar with NIDIS, you can learn a lot more about us over at drought.gov. Just head over there. You can find all sorts of great information about drought current conditions and forecasts, and you can learn more about what we do in the Southern Plains Drought Early Warning System. Welcome again to this webinar. I would like to acknowledge the contribution from some of my partners in pulling this together, partners across the region, specifically the Southern Plains Climate Hub and OSU Extension, who helped organize this webinar, and of course to our two presenters who we'll hear from later today. Before we get started, I want to go through just a few quick logistics for this webinar. Everybody is muted. This webinar is being recorded, and the recordings will be available from NIDIS on the NIDIS YouTube channel and also posted at drought.gov/webinars. The format for today's webinar will be a presentation by each of our invited experts, followed by some time for questions at the end. So if you have questions, please type them into the questions box within GoToWebinar, and we'll get to that at the end. Today, the questions will be moderated by Andres Sibbles. Andres is the director of the USDA Southern Plains Climate Hub. He's based in El Reno, Oklahoma. If any of you don't know Andres, he's a great person to get to know, and you're going to be hearing from him as he works through and reads your questions to our presenters later. Finally, I would like to introduce today's speakers. First, Gary McManus is the state climatologist for Oklahoma. He's a native of Buffalo, Oklahoma, and he's been serving in the role of state climatologist since 1999. Immediately following Gary, we'll be hearing from Katie Welch. Katie is a PhD student at Oklahoma State University, and she's working on topics including rural development and rural economies. So thanks to both of you for joining us. And Gary, I'm going to pass over to you as our first presenter. You should have permission to share your screen now.
Yes, I'm going to be covering Oklahoma's drought and climate trends. I'm really going to be talking about drought. So let's get started on the next slide. Let's see. Okay, so last night, of course, we had our promising from 5 or 6 days out the storm system. It's not like we were expecting a huge bounty of moisture. We thought we were going to get a big outbreak of severe weather. We didn't get that. We did hope at least if we were going to get severe weather, we would get some good moisture out of it. Well, this is what we got. So very little rainfall, some good rainfall up in Kay County, over an inch in that area, some streaks from the storms up in northwest Oklahoma, but by and large, nothing or less than 1/10 of an inch for the rest of the state. So unfortunately, this is what we've seen several times over the last couple of months, especially up in northern and western Oklahoma, parts of east central Oklahoma. These storm systems move through, and they really just leave us with more fire danger. So we do see this out in western Oklahoma, the red flag fire danger again. Areas that haven't seen the good green up compared to other parts of the state. And of course, we have low relative humidities. We have winds gusting 35, 45, 50 miles an hour, also over in parts of northern Oklahoma. But this is the area where the drastic green up has been delayed. So again, this is just part of a little bit of a drought in mid-spring in Oklahoma. When you don't get a green up, you get wildfire conditions generally when you get these types of storm systems moving through. Okay. And of course, that's just part of Oklahoma, a land of weather and climate extremes. This time of year, we could really expect 3 out of these 4 extremes. Of course, tornadoes, drought, wildfires. Hopefully no snow is on the way. That would be unusual, but it is Oklahoma, so keep that in mind. But When we talk about Oklahoma, that's really a part of our lore here. When we talk about disasters, Oklahoma leads the pack. Of the major disaster declarations from FEMA from the year 2000 through 2023, Oklahoma leads every state in the United States with 56, and in fact, it's not even close. The next closest is Kentucky at 42. And we're talking about things like tornadoes, severe storms, hail, blizzards, ice storms, etc. This does not include drought, however. So if you include all those drought declarations from the USDA, then of course that number goes way up. And I don't think anybody's going to catch us even if you include drought. So, but it is very unusual that we are so much above these other states. So again, part of living in Oklahoma is getting used to these sorts of things. And drought, unfortunately, over the last 10 to 15 years has certainly roared to the top of that list. We're going to take a look at our 2021 through 24 drought. We are still in drought. It's a little bit debatable where that drought ended. I'm going to say it didn't. But when we take a look at this drought over the last 2.5 years plus, it was fueled by 3 separate flash droughts. Now, it started in August of 2021 when we started that triple dip La Nina, the first year of that 3 years of La Nina. It got started a little bit slow, but it was the beginning of the drought. And then in December 2021, that's when the drought really took off. That's our first flash drought that really fueled the severity of this drought to begin with. It's very unusual to see a flash drought in December in the Southern Plains, but it was so drastically warm. It was 10 degrees above normal in December. And in fact, it's the warmest December by more than 5 degrees, which is absolutely unheard of in our modern climate record to beat a previous record by that amount for a monthly temperature. But we sure did, and we had all sorts of wind. So that's the first flash drought. We did have some relief in the spring of 2022. When we got to late June, we only had 31% of the state in drought. And then, of course, in June of 2022, we also ended all that precipitation and we had our second flash drought. And that also fueled a lot of severity and brought the drought back to the rest of the state that had seen relief earlier that spring. And also we suffered the hottest summer since 2011, that summer of 2022. And of course, in Oklahoma, those hot summers go hand in hand with big time droughts, and they do tend to fuel each other. Mid-October 22, we saw the drought peak for this whole flash drought, or the whole drought episode 2021 through 2024. That's when it was at its worst, mid-October 2022. And in fact, that's the worst, or the most amount of drought with the worst intensity we've seen since February 2013 during that horrible 2010-15 drought episode. So certainly October 2022 was not a good time in Oklahoma for drought. Now, the first half of summer 2023, once again, we had more widespread relief, drought hanging on in far southwestern and north central Oklahoma due to long-term deficits. But once again, we suffered the flash drought situation in the second half of summer 2023. So similar to the summer 2022, the rains went away and very hot conditions came back. And so flash drought flourished once again. Now, in the fall of 2023 and early spring 2024, we actually changed the ENSO, the El Nino Southern Oscillation, around from that triple dip La Nina. And finally, we switched it around to El Nino, which for Oklahoma and much of the southern tier of the United States can bring you cooler than normal and wetter than normal conditions for the cool season. We did get the wetter than normal conditions. And so by early spring 2024, we only had 3% of the state in drought. Spring of 2024, it's sort of questionable, but we do have a flashy drought situation going on in northern and western Oklahoma, also parts of east central Oklahoma. And so just in the past few weeks, our drought coverage has increased back to 15% from that 3%, the low spot that we'd seen just 3 or 4 weeks ago. So I would say, once again, flash drought plaguing the state of Oklahoma. It just depends. Next summer, fall and winter, where do we go from here? Okay. So this drought of 21 through 24, you can see, even though we do have flash drought coming back into northwest Oklahoma, starting to encroach back into east central Oklahoma, we are certainly much better off than where we were last year, where we had the exceptional drought conditions, the extreme drought conditions, and the severe drought conditions. A little bit of a moderate drought there, the tan color. But the southeastern half of the state, basically it was an I-44 relief situation. Southeastern half of the state, or southeastern to the southeast of I-44, we were free of drought, still growing strong. But you can see still this year, we're much better off, even though we have those drought conditions encroaching back into the state. So if we look back at just the last 3.5 years or so, going back to July 2021, once again here in August of 2021, as I said, this is where the drought began. We really punched up those moderate drought conditions. Again, that D1 moderate drought, about a once in every 5 years type of occurrence. But still, most of the state was not in those severe to extreme drought conditions. But then when we got to December 2021, that's when we had that December flash drought. The severity crept up and actually accelerated pretty rapidly. Here's the second flash drought after the relief in spring of 2022. So starting about June 10th, once again, that drought intensity accelerated very rapidly. And then October of 2022 was when we were at the worst part of the drought. And this was, again, the worst amount of drought that we had seen, the most amount and the worst conditions since 2013 during that horrible drought of the previous decade. And then once again, we see the relief as we got into the first half of summer and the parts of spring in 2023, and flash drought number 3 in the second half of summer. And then, of course, our relief through the El Nino winter months of 2023, 2024. And here we go at the end of that period where we are at currently with the creeping back up again. Not too bad right now, but it still remains to be seen where we go from here. Okay, current drought conditions, as we showed earlier, not too bad. Our current drought concerns, I would label those probably conditional. It depends on where you're located, obviously. So if you're down in parts of south central Oklahoma, southeast Oklahoma, parts of central Oklahoma where they've gotten the better rainfall amounts, probably not too concerned right now. But certainly if you're up in north central, northwestern Oklahoma, out into the Panhandle region, parts of east central Oklahoma, your concerns are a little bit more elevated than what you see in other parts of the state, because you are seeing that flash drought continue. And, you know, when you look at the conditions we've had over the last couple of days, highs in the 90s, mid 90s out in northwest Oklahoma, very high wind speeds, very low relative humidities. That's just doing more damage to the ecosystem and intensifying that drought. So certainly you're more concerned out in that part of the state. Like I said, a little bit of El Nino magic. Here we see Chris Farley from his famous Saturday Night Live skit. But El Nino, that warming of the waters off the west coast of South America and the associated disruptions in the atmospheric circulation patterns, what it does is it elongates and sort of strengthens that subtropical jet, brings it farther across the southern tier of the United States. But on average, it tends to bring us cooler than normal and wetter than normal conditions. Like I said, we did see the wetter than normal conditions, at least for much of the state, which you'll see here in a minute. So most of the state, this is for October 1st through April 15th, so through yesterday. We do see for the water year, lots of good rainfall amounts on here. When you look at the departure from normal through that time frame, southwestern down through south central Oklahoma, parts of southeast Oklahoma, a little bit up here in the north central Oklahoma, they do have the good moisture surpluses. That's by and large where we've reduced that large amount of drought in the state. All of this drought that was existing down in south central, up into central Oklahoma. Certainly, we relinquished the severity of the drought down in southwest Oklahoma, southeast Oklahoma. We've eliminated drought down in that region. But still, even though we had that good amount of moisture, we still have the long-term deficits, creating hot spots of drought that are able to pop up a little bit more readily in those flash drought situations. So over in east central Oklahoma, up in northwestern and north central Oklahoma. And again, that's where we see the flash drought starting to increase rapidly over the last few weeks. Now, drought concerns for the spring and summer, I would term those elevated, even though we are coming up into the wettest two months of the year. I would say that the 2 month period. So as we go from mid-April through mid-June, that's really the wettest time of year. That's the sweet spot for the rainy season in much of Oklahoma. Now out in the Panhandle, it's more into the summer months, but for the majority of the state, we are approaching the main rainy season in Oklahoma. A little bit of a secondary season in the fall. So it's a little bit premature to get too concerned. But as we do see, flash drought is it's not imminent anymore. It is actually occurring across parts of Oklahoma. And we can see from these rainfall maps from the Oklahoma Mesonet, the consecutive days with less than a quarter inch of rainfall in any single day is up to close to 100 days again up in northwest Oklahoma, up to 80 days again up in the Panhandle. Now, we were well above 100 days around Slap Out and Beaver. We did reset this map, but it's not like we got a lot of rainfall to reset it. We just got a little bit above that quarter inch of rainfall amount. So still desperately dry out in this area of the state. So we go from the percent of normal rainfall from the last 30 days, and then the last 60 days, and then the last 90 days. It's very easy to see those areas that see the drought starting to increase once again, of course, up in northwestern Oklahoma, where those areas continue to show up, this little semicircle of areas of less than 25% of normal to less than 30% of normal rainfall over the last 30 to 90 days, but also over in east central Oklahoma over the last 30 days where they're less than 50% of normal, and other little hot spots across the state that will start to show up on that drought monitor map if we don't get significant rainfall in the next few weeks. And unfortunately, as we showed with the first couple of slides, fire danger is still a concern over parts of the state. This is the relative greenness map from the Oklahoma Mesonet OK Fire Program. Basically, it takes the wettest or the greenest pixels you see throughout the year, and for the current time frame, it compares it to those greenest pixels on record. And we see the Oklahoma wheat belt showing up quite nicely. At least right now, the Oklahoma wheat crop does look pretty good. It only has a couple of months to go to harvest, so hopefully we can keep the hailstorms, any really late, unusual freeze events from coming back. But you can see out here in northwest Oklahoma, still extremely brown and yellow and lots of dormant and dead vegetation out in this area of the state. The green out here you see in the Panhandle are those irrigated fields, but you can see around those irrigated fields lots of fuel for fires, so wildfires. So when those certain conditions crop up like we see today, that's when you can get those big time fires like we saw last month there and the month of February and March as well. But also notice up here in Osage County, still pretty dry up there with not a lot of green up. So wildfire danger, until we get significant rainfall in those areas, will still be a problem, and we get some green up, which will cut down on that wildfire danger quite readily. One of the things to get concerned about when we look at these patterns, looking back in time, is we just came out of a big El Nino event. It wasn't super strong, but it was labeled strong. So when we look at the previous strong to super strong events that we've seen, 1983, 1998, 2016, the June through August periods, the summer months, in Oklahoma were hotter and drier than normal. And in fact, in some cases, they were much above normal in temperature, much below normal precipitation. So the good news here, after I try to alarm you about that, is we only have 3 data points. So it's not like we have a lot of data to back this up. Just something to keep in mind after some of these previous big El Nino events. Those summers were not too pleasant in Oklahoma. So now, if we can get a lot of precipitation in the next couple of months, maybe we can head off any troubles before they erupt in a hotter and drier than normal summer. But if this does occur, if we do see a hotter than normal conditions and drier than normal conditions, we will be looking we will be on the lookout for more flash drought conditions. Now, these maps are a little bit dated. They were released almost a month ago. There will be a new set of these maps come out in just a couple of days on Thursday. So take these with a grain of salt, but at least last month's projections for June through August that did predict, once again, increased odds of above normal temperatures and increased odds of below normal precipitation, at least for most of the state, but especially out across the western, very far western parts of Oklahoma and the Panhandle. So this would certainly not be a good thing to have happen if it does occur. And of course, this is already a little bit out of date. The drought outlook through June that was released last month, it did show drought expected to develop out across northwest Oklahoma, and of course that's already occurred. The question is, will that drought still be in place when we get to the end of June when this map is good for? Once again, that still remains to be seen. But again, we will get new maps from the Climate Prediction Center with both the summer outlook and also the drought outlook for the next 3 months. We'll get that on Thursday. So the drought concerns for fall 2024 through spring of 2025, I would call those high, simply because here comes another La Nina. I think we're pretty much past the spring predictability barrier where we do see problems predicting those sea surface temperature conditions and the INSO predictions through this spring barrier for the next fall. But La Nina is looks like much more likely now for that time frame. In fact, it's probably going to come back during the summer. Not really much to worry about in the summer months, but when we do get into the fall and winter, when that starts to impact Oklahoma, that will be something to be concerned about. Much like El Nino, when we disrupt the sea surface temperatures down here in the Equator Pacific, we see associated atmospheric circulation changes. Sort of a chicken and egg thing. Both things lead to the other. It's not really known which comes first. But what we do see is that the jet stream pushed farther to the north. And again, we're talking about a fall through early spring type impact for Oklahoma. So let's say October-ish through April-ish, but peaking in the winter months. But it does tend to bring the southern tier of the United States drier than normal conditions and warmer than normal conditions. And we do see that in the amalgam of all La Nina years. We do see drier than normal conditions, especially for the southern half of Oklahoma. But I think if you look in more recent years, you'll see that impact even more greatly out across western and Oklahoma and the Panhandle. So again, this is why I would term our drought conditions for fall through spring high, simply because of that La Nina. And you know, more often than not, when we see La Nina conditions, we do see drought conditions develop somewhere in the state of Oklahoma. So this strong El Nino is fading, and it will transition to La Nina in the next couple of months after it goes through the neutral conditions. You can see this forecast from the Climate Prediction Center. We do see the model predictions start to dip down from El Nino territory, which is above 5 degrees centigrade, above normal temperatures out in the Equator Pacific waters. And then we go through the neutral conditions, minus 0.5 centigrade to up to 0.5 degrees centigrade. And then anything below that 0.5, we get into La Nina conditions. So when we get into the May, June, July time frame, we are starting to get closer to that La Nina condition. But when we get out here into to the later in the summer months, almost certainly we will be in La Nina conditions. Again, nothing to worry about really when we see these La Nina conditions in the warm season in Oklahoma. It's really when we get into the fall through the early spring when we see those impacts start to unfold. We can see that on this bar graph. So once again, red is the El Nino. We are certainly in El Nino right now, but we do see the gray. Neutral conditions take over for the next couple of 3-month periods. When we get into June, July, August, that's when we start to see the La Nina chances go up. About 60% at the current forecast, we'll see La Nina through the June through August period. And then we get into the next fall, into the winter, we're up into the 85% plus category for that La Nina. So that's a little bit cause for concern when we get into that time frame. We look at the drought monitor time series from all the way back to when the drought monitor started back in January 2000. And again, this is just for Oklahoma, and we go all the way through the current time frame. Again, the colors are pretty easy to determine. If you see the reds and the darker colors, those are the higher intensity droughts. But you do see these La Nina conditions. So each one of these brackets is a La Nina, and yet you can see those match up pretty well with the drought conditions in Oklahoma. So La Nina 2001, 2002, not too bad a drought, but it was certainly devastating to the Oklahoma wheat crop back then. 2005, 2006, a pretty stout little drought right there. Once again, a devastating drought for the wheat crop, but also a very terrifying wildfire season. One of our worst wildfire seasons on record occurred from that late fall 2005 through early spring 2006, 2008, 2009. Again, the biggie of 2010, 15. Certainly, we didn't have the La Nina conditions throughout that entire frame, but we really got it started with one of the strongest La Ninas on record back 2010, 2011. That really got us started. And then, of course, that worked through the 2011, 2012 period as well. 2017, 2018, another La Nina period. And then, of course, our triple dip La Nina that really kept us in drought for the last 3 years. So I'm not just making this up when I say the La Ninas tend to bring us drought conditions in Oklahoma. They can certainly get us started in the cool season, headed towards that direction. They tend to cut us down a little bit on that precipitation in early spring, and that tends to set the scene for the rest of the spring through the summer months. It really gets those droughts started. So again, that's the reason for the concern for drought as we get into to the cool season and into early next year. So forecasts and outlooks. So for the next 7 days, we do continue to look dry up in the northwestern part of the state where that flash drought is continuing to intensify. Better chances down across southeastern Oklahoma, of course. Now, you're going to say, what else is new? But this is basically climatology for Oklahoma. So increasing amounts down in the southeast. But we do need to get significant moisture up here in northwest Oklahoma, north central Oklahoma. Maybe we can alleviate some of these drought concerns up here in east central Oklahoma, however. But again, the northwestern third looks to remain mostly dry. When we look at the outlooks for basically through next week from the Climate Prediction Center, we do see increased odds of above normal temperatures. That would not be welcome considering we have flash drought conditions and we're getting well into the warm season. Like I said, increase in temperatures does go hand in hand with increasing drought, but we also see increased odds of above normal precipitation. And again, this is during the rainy season. So when we see above normal precipitation odds increased in the rainy season, that's a good thing. We just have to have this happen finally. Not only down here in southeast Oklahoma and south central Oklahoma where it keeps happening up in central Oklahoma, but also out here in northwest Oklahoma. They really need to get their share of moisture as well. Okay, my final thoughts. So drought has faded considerably after nearly 3 years, starting back in August 2021. Thanks for help. Thanks for the help from El Nino. It certainly did get us in a better situation this time of year than when we were the last couple of years. The drought had 3 smaller episodes, each started by a flash drought, making one longer drought episode. I still think we're in the same drought episode. I still think we're considering this 2021 through 2024. I don't think if we do go back into drought, I don't think we're starting in a whole new drought. I think this is one longer period drought. El Nino, it's fading. This is normal for this time of year. La Nina is probably next. This is also normal. It's normal to see La Nina develop after a strong El Nino event. So nothing unusual there. And finally, there will still be drought in Oklahoma after this week, no matter what type of rainfall we see. In other words, drought isn't going away anytime soon, unfortunately. So we'll just have to see where we go from here. And that's it for me. Thank you.
Thank you, Gary. That was fantastic. I learned so much. Thanks for sharing all that information with us. I'm next going to pass the presenter permissions over to Katie from Oklahoma State. Katie, you should be able to share your screen now.
Perfect, thank you. So what we're looking at from my presentation are the economic impacts of drought and the effects of disaster relief insurance on Oklahoma's rural communities. So this is going to be more of like an in-depth case study on what's happened in a couple counties as opposed to the entire state, but the concepts are transferable. So I've been working on this with a few people at Oklahoma State that are listed there. So the problem, what we're looking at is what are the economic losses experienced by communities in Tillman, Jackson, and Harmon counties due to drought. And so the first thing we think about drought impacts are probably those crop and livestock sectors, but we know that it trickles to more sectors of the economy than just the crop and livestock ones. So what factors make the producers more resilient to drought? So how are they able to mitigate the effects of drought with their risk management strategies, and specifically what kind of effects do those disaster relief insurance programs offer? So there are a lot of things saying, hey, you should enroll in these, they're really beneficial, but how much do they actually help? So you'll recognize this from the last presentation. This is the drought monitor, and like Gary said, the darker colors represent more severe drought. So we have that period from 2006 to 2007. The 2011 to mid-2015 was a pretty bad period. We also have that 2018 period and the 2022 starting one. So the methodology in this study is going to cover all the years from 2000 to 2021 because that's what we have data for. But a lot of times we're going to break it out and just look at that 2011 to 2014 drought to kind of make examples of things. So again, the darker colors indicate more severe drought. You can see in 2011, nearly over half the state was in that D4 exceptional drought. In 2022, whenever I snipped this picture, it was mostly the western part of the state, and the area we're going to be looking is going to be this little southwest corner down here. So we'll show the study region in just a minute. So like I said, we're looking at the effects of drought, and we expect some economic loss in both our crop and our livestock sectors, but we also expect to see some trickle-down effects to other sectors. And besides this, you also have effects including water restrictions, brush fires, the loss of recreation due to low lake levels and low water levels. So those are just some other things to consider when we're thinking about drought. And the way we really want to think about this is we're going to use input-output analysis to estimate how this works, but it's based on export-based theory. And so that just says that some region produces a good or service. So in this instance, maybe it's wheat. And then that good is demanded outside of the region. And then that demand generates income as people purchase this wheat. And so IO extends this theory to sales, where those sales bring the income into the region. And then as that income is respent, you generate this multiplier effect as it gets respent multiple times throughout the local economy. And then that effect size is just determined by how many rounds of local purchasing it goes through. So a way to think about this visually is if we start with this center box that says direct effects, we have crop producers who experience change in their yields and change in their harvested acres. And then we have our livestock producers who have changes in their herd size and their herd composition as they sell off livestock or have to cull some of their cattle. And so if you go left on that figure to the backward linkages, you can think about these as supporting sectors. So these are people that our crop producers and our livestock producers are buying inputs from. So this could be seed, it could be fertilizer, it could be feed for their cattle. And so as they experience this drought, and I'm pretty sure that none of the farmers who realize that, you know, their crop is going to fail, they're not going to throw extra fertilizer out on it, right? So that's a decrease in an input that they've purchased. And so that changes the dollar amount of purchased inputs. And as these dollar amounts add up, that results in a change in the amount of labor employed in those input industries. And that is where we get our induced effects, where you have a change in your household spending because these people no longer work as many hours at their jobs as they would have normally if this event hadn't occurred. So that's our input sectors. That's one portion of the effects we're going to see. But then we can also go to the forward linkages on the right side of that middle box and think about the change in output sold. So if we're talking about wheat, this is like they don't have as much wheat to sell to millers. So the millers experience losses because they no longer have that wheat to purchase and they can't sell it to other intermediate processors or final markets. And so the point of input-output analysis is we're able to collect all of these effects and sum up and see the whole economy effects. So another thing, my arrows were supposed to come at different times, so that's another thing we're gonna have to live with. But so multi-regional input-output effect models, they capture the effects in linked regions. So in a regular model, you'll be able to see what happens in your region, but anything that leaves it is gone. When you have multiple regions, you can trace those effects into your neighboring regions and see what happens before, you just get to see more of those impacts. And of course, anything that leaves the region is a leakage and you can't follow that anymore. So the way that looks in Oklahoma, and in this study, so our main impact region is that dark red 3-county region of Jackson, Harmon, and Tillman counties down the southwest corner. So our impacts are going to start there. They're going to flow into the Kiowa and Greer County region and into the rest of Oklahoma, which is our 3rd region. Anything in a blue arrow is lost outside of the region and we can't track that money anymore. So what we're essentially seeing here is that we can follow those effects into Kiowa and Greer, we can follow it into the rest of Oklahoma, and then we can also see the feedback as they move through those regions between each other. And so we really just capture a lot more of the impacts that way. Data from this project mostly came from the USDA, National Agricultural Statistics Service, looking at crop yields, harvest, things like that. We also got some data from the Risk Management Agency, and that was on our insurance indemnity payments, and the Bureau of Economic Analysis. MPlan is the software that we're using, and it also has our underlying economy data layer. And like I said earlier, we're looking at all the years from 2000 to 2021 because we want a longitudinal view of how drought has looked in the economy as a whole over this time span. We're going to talk about a couple different kinds of effects, and I just want to go over those real fast so that people unfamiliar with the terms know what we're talking about. So the first type of effect is going to be output, and that's basically your sales, receipts, operating income. You can think of it as revenue. So this is the amount of money you're generating before you take those costs and things out. The second type of effect is going to be employment. This is the total number of jobs, and that includes full-time, part-time, and seasonal employment. And then value added is the last one. It's a little tricky to think about, but it's basically your industry's contribution to GDP. And some people like to compare it to profit. So if output is our revenue, value added is really our profit. The last thing I wanted to say here is that these effects all occur within a 1-year time span. So for the most part, we'll be talking about individual years. And if we extrapolate from that, I will say. So this is the contribution of agricultural sectors within Jackson, Harmon, and Tillman counties. This means this slide is basically telling us what the existing activity of the agricultural sectors contribute to Oklahoma's economy. And then you can think about it, if these sectors did not exist, what would happen? And so from our calculations, we found that agriculture contributes 2,800 jobs, $518 million in output, and $175 million in value added. And that's just in those that three county region. And then the next thing I wanted you to notice here is down at the bottom of the slide, some of my labels have disappeared, but those 4 main columns that are orange are all direct impact industries, meaning it's like cotton, grain farming like wheat, and those agricultural sectors. But that 4th one you're going to see is the 4th largest one impacted, and it's all yellow and green. It's all indirect and induced effects, and that's the financial, insurance, and real estate industry. And that's just showing that even though it's not one of the agricultural industries, it is one of the top impacted industries because of how closely related it is to those agricultural sectors. So they buy a lot of services from that sector, and you can see that. So that means that when they experience these drought impacts, the financial, insurance, and real estate industries are also going to experience them very heavily. This is just talking about how the impact calculations are done. And what we're basically doing is we are estimating what the average revenue would be in a year. And then we're taking the actual revenue that these producers received and subtracting that potential revenue from it. And the difference in those is going to be our drought loss. So if they could normally harvest this many, acres, getting this much yield at this price, but in the drought that's reduced, we're going to see that negative shock. And then to incorporate the effects of insurance, we're just going to add that insurance indemnity payment back into the calculation. And then the last thing I wanted to talk about on this one was we have to think about livestock. And livestock is not like crop production, because crop production generally occurs in year cycles, right? You plant, you harvest, and then you're ready for next year. Livestock, especially cattle, you almost have to treat more like an asset, because you keep some of these, especially in Oklahoma, you keep cattle as breeding stock from year to year. And when you're in drought, your producers aren't automatically going to sell off cattle. When we went and spoke to them in the region, they're more likely to hold on to their cattle. They want to protect the genetic integrity of their herd, and they'll wait to sell any off, because that's just something they want. And so we have to think about, how does that look in drought? And so our solution was to look at the change in inventory, change in the value of the inventory, because as cattle prices change and as the composition of the herd changes, that value changes, and that's going to reflect our livestock impacts. So here, these are just those calculations we've done. What are these agricultural industries losing directly? So in that red column, what I wanted to point out is that the impacts in 2011 are relatively higher than our other years, and we're going to notice that that trend holds after we put it through the model. In 2012, you're going to see that positive number for wheat, so $27.4 million. And you may think, okay, why do we have a positive number for wheat in a drought year? And that's because there was actually a bumper wheat crop in that year. And then you'll also see those positive numbers for cattle, for livestock, down in 2013 and 2014. And again, it's because cattle prices were so high. There was a major cattle cull in following 2011, 2012, and that lowered supply pushed the prices of these cattle up. So that's why we see those positive values when everything else is negative. And so just thinking about this visually, what we're doing is we're imposing those negative shocks to those agricultural industries, and then they're shocking the rest of the economy, where we get those changes in jobs, output, and value added. And so our result, and again, this is just our 2011 to 2014 years. I didn't want to present you with a 20-year table. That would be a lot to look at numerically. So in 2011, again, we do see they have relatively higher impacts with $332 million in output lost, 2,200 jobs lost, and $141 million in value added. If you average across all those drought years, that one drought period had an average of $166 million in output lost per year, 1,110 jobs lost, and $69 million in value added lost. And again, that averages per year, so for each year of the drought occurring. So one thing we wanted to talk about was, we have that disaster relief insurance, and after we add this effect in, how does it change? And so if you'll just skip straight to the bottom of the table, we have those totals. So the total impact from 2011 to 2014 was $662 million in value added. But after we included those disaster relief insurance indemnity payments from the risk management agency, that dropped our output loss from $662 million to $309 million. And so it was reduced by 53%, which is phenomenal. And then we can see in employment, we also had a 50% drop, and then in value added, it was a 45% drop. So these disaster relief payments make a big difference to these producers and to the people in the economy that they're linked with, or the sectors of the economy that are linked to them. Another thing, sorry, my boxes have moved again. So this is just the industries that are affected, and it's going to be our top 5 and bottom 5, which are our quartiles. And so in 2014, you'll start in that first, right where lower quartile says, you'll see that grain farming had an impact of nearly $28 million lost. But then after you add those insurance payments in, grain farming actually goes to the very opposite end of the spectrum. It's at the very top of our upper quartile with a gain of $12.5 million in output. And that's because with those payments coming in, they could still afford to perhaps purchase inputs for next year, still make payments on anything they had to in their production activities, just whatever they were spending money on before, they were still able to do that as a result of those payments. This is a quick look at the output with the output loss over time. So this is from 2000 to 2021. So you'll see that there's a 0 right at a little over halfway up that axis, the y-axis. That 0 would be representative of a perfectly average year. And so we don't really hit that often, right? And we wouldn't expect to. And so what we see is in these non-drought periods, we have this above 0. So they have better than average years. So they have positive output. And then whenever it drops below that 0, those are our drought periods. And so you can see that, if my labels were there, that 2011 to 2014 drought period was pretty severe, but the difference between the blue and the orange line is actually the difference between our output and then what our output is with the indemnities. So you see that those indemnities, they moderate those drought periods. In non-drought years, they're pretty much overlaid on each other because you wouldn't expect those payouts in years where you don't have drought. But in those years where you see that blue line really take a dive, you see that orange line pulls it back up. So those indemnities really do counteract some of the effects. You can see again that those peaks would have occurred right where those most affected years were. This is the last one I wanted to show you, and this is just looking at those drought impacts with the soil water. So the blue line again is our output, the loss, and then that gray line is our soil water. And conveniently, they have nearly the same units. They're both in negative millions, but one's in dollars and one's in cubic meters, so we have them on the same line. And you can see that there is quite a bit of correlation between those, the soil water and the effects on output. So in conclusion, what we really see is that there are large losses in drought periods. For instance, in the 2011 to 2014 period, we saw an average loss of $166 million in output, 1,100 jobs, and $69 million in value added. But there are mitigating effects. So diversification really is a great risk management strategy. For producers who had wheat in 2012, they didn't suffer the same impacts as people who were perhaps only farming cotton or only had livestock. The same thing in 2013 and 2014 with those record high cattle prices. Those really helped to mitigate effects as compared to like the 2011 year where everything had high negative impacts. And then another really important thing is those insurance indemnity payments. And you can see that noticeable effect in drought periods versus those non-drought or those less severe drought periods, how they really curb that effect that the drought has. And this is just the my contact info, and then Dr. Dayton Lambert is actually the lead on this research project. So you can email either of us with any questions you have that you don't get answered in the webinar. I'm sorry for all the format issues. I didn't realize were going to happen when I moved it over to this webinar, but I really appreciate you all taking the time to listen.
Thank you so much, Katie. That was great. Really interesting information. Andres, are you on? If Andres is still on, I'm going to pass over to Andres to moderate the questions.
Yes, thank you, Joel. I still am. I have a question here for Gary. Gary, you mentioned flash droughts a number of times in your presentation. Could you tell us what the difference is between a flash drought and just sort of regular drought?
Right. So flash drought is basically what it sounds like. So when you think of a flood versus a flash flood, a flood is something that happens over a certain period of time. A flash flood is a flood that happens very rapidly with a lot of rainfall. So when we talk about a drought, you're talking about possibly taking months to seasons to develop with the mounting deficits. When you talk about a flash drought, that's simply a drought that it develops much more rapidly. Basically due to above normal temperatures and sharply shrinking amount of precipitation. So, when we look at what happened in June of 2022, on June 10th, it's very weird to be able to track a drought down to its beginning day. But on June 10th, the temperatures increased by about 20 degrees from where they were the day previously. And all the rain we'd received previous to that went away. We didn't get any good rainfall for the next 2 to 3 months. And so there you had a very rapid drought situation, very rapid drought development. So flash droughts, generally something that you would think happen during the summer months when we do get those extreme temperatures and the lack of rainfall. But again, as we showed previously, they can happen pretty much anytime in Oklahoma.
Thank you, Gary. One other question for Gary here. Is it possible to predict the likelihood of having multiple back-to-back La Niñas as the triple dip one we had recently?
Can't really predict the IMSO likelihoods out past the year. What we do know, though, is that La Niñas tend to come more in doubles. Now, triple dip is extremely rare, but we do tend to get, especially over the last 20, 25 years, we're getting more La Niña episodes than we are El Nino episodes. I think that has to do with the orientation of the temperatures in the Pacific, what's known as the Pacific Decadal Oscillation. When it's in its cool phase, we do tend to get more La Niñas. And it is in its cool phase. That can last 25 to 30, 50 years. So, you know, if you look over the last 25, 30 years, that probably accounts for why we're getting more La Niñas than El Niños. But certainly, you know, in Oklahoma, we would rather see an El Nino than a La Niña. Now, unless you're talking about like the 2015 Super El Nino that brought so much flooding in the state. But, you know, when we look at just the forecasting or the outlooks, we're really just looking out to the next year. We can't really go past that.
Thank you, Gary. That explains a lot. Thank you so much. Katie, there is a question for you. Have you all looked at what are the impacts of drought on ag land values, agricultural land values?
That is an excellent question. So that is not something we've done as part of this study. I think it probably has been done in previous literature, but I'm not really familiar with it. And like I said, it's not part of this study, so I can't tell you what that is, but I'm sure it does probably have an impact.
Thank you, Katie. One other question with two parts to it. The first part is, when you looked at livestock, did you separate sort of a typical cow-calf from a stocker operation? And did you find similar effects in both? That's one part of the question. And the second part is, do the insurance programs, how much do the insurance programs assist in preventing destocking from a typical cow-calf and having to cull cows in a drought?
Both of those are excellent questions. So the first one, due to how the data was set up, we could not separate that out by type of operation. We just had to look at the livestock industry as a whole. And that's why that sector was also simply labeled livestock rather than, you know, cattle or poultry. It's because everything was all together. But that would be very interesting. I do expect that there would be differences there. For the second part of that, about the livestock insurance question, that I don't know in particular what exactly how that assistance works. I'm a little more familiar with the crop insurance, so I couldn't tell you exactly how they keep from having to, you know, do those culls and things. But one of the major problems with cattle is that, you know, they're a living animal, and so they have to eat. And what happens in these extreme periods of drought is that even if the producer has the necessary funds available to purchase feed, there may not be feed available. So you'll see a lot of times with these droughts, you also don't have those hay harvests and those grain harvests and things like that. And so there's a high shortage of feed, as well as a shortage of available like grazing and pastures and things. So they end up having to cull their cattle whether they can afford to keep them or not, because they just don't have the available supply that they would need.
Thank you, Katie. That is great and very interesting. Thank you. Thank you so much. And Joel, I will pass the mic back to you.
Thank you, Andres. Just to wrap up, I would like to extend one last thank you to Gary McManus, Oklahoma State Climatologist, Katie Welch, a PhD candidate at Oklahoma State University, and also to you, Andres, the director of the USDA Southern Plains Climate Hub. Thanks all of you for taking your time and sharing your expertise with us. That concludes today's webinar, and I will be sending out an email with the recording of this when it becomes available. Thanks all. Bye-bye.